Good morning to SAT scholars. We're going to start a new unit today on SAT type problems that you could encounter involving linear expressions or equations. So here's a simple two-step equation. Just want to remind you, maybe you did this back in Algebra 1. First thing you want to do is get rid of what I like to call this little trailer guy, right? Because we're going to solve two-step equations in reverse PEMDAS order. So we just bring down the a over 4. Now we have to get rid of the a is the variable, so we got to get rid of the 4, and we can do that by multiplying both sides of the equation by 4. So you get 16 is equal to a, since those 4's cancel out. Now in this case, the trailer is a -6, and in order to get rid of it, we've got to add it to both sides. So we'll get x divided by 4 is equal to 1. Now again, to get rid of that 4, we're going to multiply both sides of the equation by 4. They'll cancel here, and you'll just get x is equal to 4. This next one, we're just going to add 7 to both sides to get 9x is equal to 0. And 0 is okay, it's just a number. Next step is to divide by 9, because we want to get it away from the x. So x is equal to anything dividing 0 will still equal 0. And this last little warm up, if we subtract 4 from both sides, we'll get -4 is equal to n over 5. So we want to get rid of the 5, so it's division. So inverse operation would be multiplication. So you multiply both sides of the equation by 5 to get -20 is equal to n, since those 5's cancel out. All right, so that's just a little linear equation warm up for you. All right, we're going to jump right into some more interesting problems here. Oh, actually, first I wanted to go over this question from the strategies quiz. So they're telling you that AE is parallel to CD. So if these are parallel, then, and they also say that AD intersects CE at point B. So what that tells us is that AD intersects CE. Oh, okay. So they're just pointing out that those two intersect. Okay. And they're wanting to know what is the length of CE. So notice you already have part of CE. So what you need to find out is what that part is, right? Because you can say that X, well, let's say CE equals X plus 8. All right, well, what we have here are similar triangles. So if you mark these, we know that this angle is the same because it's vertical angles. Now, if we call this triangle CBD and the other triangle ABE, we have similar triangles, right? So since these lines are parallel here, and let's say this is a transversal, we can say that this angle is the same as this angle because they're alternate interior angles. And what we have left is this third angle. So what we're trying to find out here is what side is similar to what other side of the bigger triangle, right? So if we name this CBD, we went 3, 1, 2 tick marks, right? So we have to name the other one EBA. So we're doing BE. So that's the same as EB, right? So we're saying that EB is to CB as, let's say, BD is to BA. And I'm just looking at the order of those letters. So we know that EB is 8. They gave that to us. And CB is what we're calling X. But we do know what BD is. BD is 5. And BA is 10. So because we have parallel sides, we necessarily have similar triangles, and we can set up a ratio like this in order to solve for X. So if you do product of diagonals, you can say that 80 is equal to 5X. And divide 80 by 5, you get 16. But remember, we said that CE is going to equal to X, which is 16 plus 8. So this is very typical of an SAT problem. In that it's a two-part question, right? So you're always wanting to look back at the original question and make sure you're answering the question that they are asking, because they frequently try and mess you up. Because notice that we got a value here, we would be done if we're in algebra class, right? But then they go on to ask part 2. This would be part 1. So if y'all have some attempts left on your strategies quiz, you can go ahead and use that. Okay, so here's another type of linear equation, and I should have said what makes linear. Linear is when the exponent is 1. So notice that the exponent to the variable is all 1. It's called quadratic when the exponent is a 2. Okay, so there's a great shortcut to solving problems with fractions, and that is to multiply everything in the problem, both sides of the equation, by the LCD. The LCD is the number that 4, 2, and 5 can all go into evenly, and that would be 20. So we're going to just multiply everything by 20, and I'll show you, you'll like this because all the fractions go away. So 4 goes into 4 once, 4 goes into 25 times, and you would just do 5 times whatever's left, which is 11A. 2 goes into 2 once, 2 goes into 20 10 times. 10 times 5 is what you have left. 5 goes into 5 once, 5 goes into 24 times. 4 times 58 is 232. Oh, actually, let me write what I'm doing there. I'm doing 4 times 58. Here's the minus sign from the problem. 5 goes into 5 once, 5 goes into 24 times, and I'm left with 4 times 9. Oops, 4 times 9A. So then you just simplify that. So you'll get 55A plus 50 is equal to 232 minus 36A. Now in this problem, we've got variables on both sides of the equation. So we're going to first collect the variables to one side. So I'm going to bring 36A to the other side. So I've got, let's see, 11, 91 A's plus 50 equals 232. Now I want to get rid of this little trailer, so I'm going to subtract 50 from both sides of the equation to get 91A equals 182. Then I'm going to divide both sides by 91. These will cancel, and I will get A is equal to 2. All right, let's practice with another one. Think about the LCD. What would the LCD be for, and when you look at what the LCD is, you want to consider all the denominators. So what's the LCD, or what number do 2, 4, and 8 all go into evenly? And that would be 8. So we're going to multiply everything by 8. So we'll get 8x. 2 goes into 2 once, 2 goes into 8 4 times. So we'd have plus 4 times 5, which is left. 4 goes into 4 once, 4 goes into 8 twice. So we'd be left with 2 times 7. Here we're just left with 8 times 7. And these 8s completely cancel out, and we're left with 19x. If you simplify this, you'll get 8x plus 20 plus 14 equals 56 plus 19x. Add like terms here. We have 8x plus 34 equals 56 plus 19x. Now I can get the variables on the same side. So I have 34 is equal to 56 plus 11x. Subtract 56. You get 11x is equal to negative 22. And then divide both sides by 11 to get x is equal to negative 2. Okay, so that's an LCD problem. If you come across fractions, you know what to do. Another type of linear sort of question that you could get on the SAT is what we call these literal equations, where there's no numbers and they just want you to solve for a particular variable. Well, this is the variable that we want to get by itself. Okay, so we want to get rid of everything else. So just as if A and B were numbers, to get them away from C, you would just subtract them. So we're going to subtract A and we're going to subtract B from both sides of the both sides of the equation. So you'd just be left with P minus A minus B is equal to C. So that's what it means to solve for C. You're getting C by itself. In this next problem, we're solving for L. Oops. So here's L. Now what's near L is the W and the H, and they're being multiplied. So to get rid of them, the reverse of multiplication is just division. So we're going to divide both sides by the things you're trying to get rid of. So these cancel out, and you're just left with V over WH is equal to L. Okay, they do point out here that these are popular formulas, right? For perimeter of a triangle would be perimeter equals all the side lengths, right? But let's say you knew the perimeter and only 2 of the side lengths and wanted to find the third side length. This is helpful. Okay, let's do some word problems here. It says the perimeter of a rectangle is 294 centimeters and the width is 57 centimeters. So the first thing you're going to start with is the perimeter of a rectangle. Perimeter of a rectangle is going to be 2 times the length plus 2 times the width. And let's fill in what we know. We know the perimeter is 294, and we know the width is 57. So we've got 294 is equal to 2L plus 114. So you just solve the equation, right? So you're going to subtract 114 from both sides. So you'll get 180 is equal to 2 times the length. From here, you're just going to divide both sides by 2 to find the length is equal to 90. Okay, let's read the next one. Blake Moore must build a rectangular storage shed. He wants the length to be 6 feet greater than the width, and the perimeter to be exactly 44 feet. Find the length and the width of the shed. Okay, so what do we know? We know that perimeter is equal to, let me just circle these so you know where I got them. Perimeter is equal to 44. And let's say the width is equal to X. Then the length has to be 6 feet greater than the width. So it would have to be X plus 6. Okay, so let's use our perimeter formula again. Perimeter is 2 times the length plus 2 times the width. So we know the perimeter is 44. And we know that the length is X plus 6. And the width is just X. So we're just going to solve the equation. So we're going to distribute here. So we have 2X plus 12 plus 2X. Let's add like terms. So we have 4X plus 12. And then subtract 12 from both sides of the equation to get 32 is equal to 4X. And then divide both sides by 4 to get X is equal to 8. Okay, in these next problems, they really like to put these on the SAT. So they'll even give you one of these trips here. So what you need to know here is that distance is equal to rate times time. So rate times time equals distance. So in the morning, she drove to a business appointment at 50 miles an hour, and average speed on the return trip was less, right? 40 miles per hour. And the return trip took a quarter hour longer because of heavy traffic, right? Which makes sense. How far did she travel to the appointment? So what we're really wanting to know is what is the distance, right? So in the morning, her rate was 50 and her time, we're just calling it X. So we can multiply those and say that's 50X. And And in the afternoon, her rate was 40 and her time was whatever her original time was in the morning plus a quarter of an hour longer. So we can say 40 times x plus 1/4 is an expression for distance. Well, on these distance problems, what you have to realize is that her business appointment was the same distance away, right? So these two distances must be equal. And what we want to know is what that distance was. So if we put 50x equal to 4x plus 1/4, notice there's only one variable. If we found x, then we could multiply it by 50 and figure out what the distance is, right? Because that's what they're asking you for. And really, they're asking you for not the whole distance, but the distance to get to her appointment. We're just going to solve this equation. Distribute here and here, get 4x plus 4 times 1/4 is just 1. Oops, this should have been a 4. Shoot, let me fix this. Should have been a 4D. So that would be 40x plus 10. Let me rewrite that so it's not so messy. And then we're just going to solve the equation, right? We're going to get the variables on the same side. So you'll get 10x is equal to 10, and then divide both sides by 10. And you'll get x is equal to 1. Now remember, this is a two-part question, right? They're not asking you what is x, they're asking you what is distance, right? So part 2 of this SAT kind of problem would be to find out the distance. Well, we know that distance is equal to rate times time, right? So distance would be equal to the rate of 50 times the time, which was, we called x, right? And we found out is 1. So the distance she traveled was 50 miles. All right, a variation of this kind of problem will come next. And this is one of the problems that students really have a hard time with, but I'm going to give you a formula that makes this work every time. If you make a table up and make this strength, and sometimes they'll give that to you, make this the amount, and make this the total. And you're always going to make up a table like this. And this is your starting concentration. This is what you're going to add. And this is your result. So let's read the problem again here. So how many gallons of a 5% solution? So how many gallons of a 5% solution? So here's your variable. And this is what you're adding, right? You're adding 5 gallons. And the result of the actual gallons you would have is whatever you started with and add 5 in, right? Okay, now it says it's mixed in with 5 gallons of a 10% solution. So here's what it's mixed in with, 10% solution, and what we want to get to obtain, meaning the result, is we want to get 7%. So if you know how to fill in the table here, the actual work is pretty simple, because like the distance, rate, and time, the strength times the gallons of solution would be the gallons of pure acid, right? So if you multiply these, you'd get 0.05. That's how you write 5% as a decimal, times X. In this one, you would write 10% as a decimal is 0.10 times 5, right? I'm just multiplying straight across. And here you would write 0.07 times X plus 5. So I'm just straight across multiplying, right, to get those. Well, what we know is that these two must be equal to the final solution, right? Because you have a certain amount of 5% acid, a certain amount of 10% acid, but the amount times how much you have must equal the final result, right? Because you're adding two things together and having the final result. So 0.05 X plus 0.10 times 5 has to equal the resulting solution, right? Because one, you started with 5%, you added some 10%, and now you have a final solution, which is going to be 7%. So they must equal. Okay, so if we solve this equation, we're just simplifying 0.10 times 5 is 0.50. And here we're just going to distribute 0.07x plus 0.35. And then let's get the variables together on the same side. So I guess I would subtract 0.05x. To get 0.50 equals 0.02x plus 0.35. And then subtract 0.35 from both sides of the equation to get 0.15 is equal to 0.02x. I'm going to divide both sides by 0.02. We'll get x is equal to 7.5. So in some of the problems, I'll fill in some of the data for you, and some of the problems you'll have to fill in your own data. So let's answer the question, which was how many gallons of a 5% acid solution, right? And that would be this X, right? You just solve for that, so your answer is 7.5 gallons. All right. Okay, so this one I'm not giving you a table, so we're going to fill it out ourselves. So we know this is going to be strength. This is going to be the amount, and this will be the total. We're talking about sand here. So we're going to start with something, we're going to add something, and we're going to have a result. Okay, so what did we start with? 2 cubic meters of soil with 35% sand. So we started out with 2 cubic meters of strength, 35%, was mixed into, oops, sorry, I put that in the wrong place. Here we go. All right, so we started with 2, the amount, right? Started with 2 cubic meters of soil that had 35% strength. Was mixed into 6 cubic meters of soil. I suppose we could have put this down here just because of the wording. All right, so it was mixed into 6 cubic meters. So really, we started with 6 cubic meters since the other 2 cubic meters was mixed into it. So 6 with 15% sand. So the total sand is going to be, you're going to just multiply straight across. So you'll get 6 times 0.15. And here you'll get 35 times 2, 0.35, I mean. So the starting was equal to 0.9 cubic meters. And the 2 cubic meters ends up being 0.7. All right. So what is the sand content of the mixture? So the result is the finished product, right? So the sand content means the strength. So that's what we don't know. But we do know that the total amount of sand, if you start with 6, sorry, if you start with 6 and add 2 more, is going to be 8, right? So you add these to get 8. And if you add these, you get 1.6. So remember, what we know is X times 8 must equal the total over there, right? Just like they do in all the other columns. So what we have here is 8X is equal to 1.6. And then we just solve that equation by dividing both sides by 8 to get X is equal to 0.2. Now remember what the question was, the sand content of the mixture. So the sand content is in percentage, right? So 0.2 is equal to 20%. So the sand content of the resulting mixture is going to be 20%. Okay, one more example. Let's start out with our table again. Strength, amount, total. And this time we're talking about peanuts. Over here, there's the starting mixture. then whatever we add to it. And then finally, the result. Oh, I did that again. Okay, let's see. You can pause the video right now and see if you can fill in the table by yourself. All right, let's see. Let's read it a little bit at a time. 9 pounds of mixed nuts with 55% peanuts was mixed with, so let's say that we start out with this, 9 pounds of mixed nuts. So we start with 9, 55% strength. Was mixed with 6 pounds of a different kind with only 40% peanuts. Question is, what percent of the new mixture is peanuts? So again, in this problem, we don't know what the mixture is. But remember, you're going to multiply straight across. So here we'll get 9 times 0.55. And here we'll get 6 times 0.40, which is equal to 4.95. And this is equal to 2.40. Okay, because we're multiplying straight across. Now, they want to know what X is, right? So what we can do to fill in these other blanks is add these two, right? If we start with something that's 9 pounds and add 6 more pounds, we've got 15 pounds. Same here, if we add, right? Because remember, two things together will give you the result, right? So if you add 4.95 and 2.40, you get 7.35. So you look, all right, where's my variable? It's in that result. And we know that if we multiply these two, it has to equal the number on the right, right? So we've got 15x equals 7.35. Divide both sides by 15, and you'll get x is equal to, where am I? 0.49. So this is going to equal 49% for new mixture. All right, your assignment is posted on Schoology. Have a great weekend, guys.